Hello. Today we are taking notes over simplifying trigonometric expressions. Our essential question is, how do we use trig identities to simplify trigonometric expressions? First, we're going to start off by looking at our fundamental trig identities, and we start off with the reciprocal identities. You can recognize reciprocal identities because it's 1 over some quantity. So our first one is sine of theta equals 1 over cosecant of theta. Right next to it you can see cosecant of theta is equal to 1 over sine of theta. Then we continue with cosine of theta equals 1 over secant theta. Secant theta equals 1 over cosine theta. Tangent theta equals 1 over cotangent theta. And cotangent theta equals 1 over tangent of theta. These reciprocal identities are found at the top of your turquoise paper of identities that I gave you earlier, so you can just take a look at that and make a note of the identities you see there. Let's continue on. The next set of identities that we look at are called the quotient identities. Why are these called a quotient identity? Because you'll notice that tangent and cotangent are represented by sine divided by cosine and cosine divided by sine, respectively. So they're quotient identities because they have a fraction or division involved. So tangent is sine over cosine, cotangent is cosine over sine. Our third set of identities, which we will be using frequently, are the Pythagorean identities. The first one is sine squared theta plus cosine squared theta is equal to 1. The second one is 1 plus tangent squared theta is equal to secant squared theta. And the third one is 1 plus cotangent squared theta equals cosecant squared theta. Now, on your turquoise paper of identities, you'll notice that we have some additional ones underneath which can be derived from these that we already have listed here. A second one that you'll find on your paper, if I subtract cosine squared theta from both sides, I end up with sine squared theta is equal to 1 minus cosine squared theta. So there's my second one. And then the third one is like it. If I subtract sine squared from both sides, I end up with cosine squared theta is equal to 1 minus sine squared theta. And then underneath the 1 plus tangent squared theta equals secant squared theta, we have two additional ones. If I subtract the 1 to the other side, I end up with tangent squared theta is equal to secant squared theta minus 1. Or if I subtract the tangent squared to the other side, I end up with 1 is equal to secant squared theta minus tangent squared theta. Now the order that you write these in matters because it's subtraction, so it's not commutative. So it needs to say secant squared theta minus 1. It needs to say secant squared theta minus tangent squared theta. And the same thing over here with the sines and cosines. The order matters when you subtract. And then for our third set, 1 plus cotangent squared theta equals cosecant squared theta could be rewritten as, if I subtract 1 from both sides, I could rewrite it as cotangent squared theta equals cosecant squared theta minus 1. And an additional way of writing it, if I subtract the cotangent squared to both sides, I could write it as 1 equals cosecant squared theta minus cotangent squared theta. So these are your identities. We're going to be using them here in a moment to simplify some trigonometric expressions. So go ahead and pause and then we'll move on to some examples. Okay, example number 1. Cosine theta, tangent theta. We want to simplify it using our identities. So the first thing I'm going to do is one of the best ways you can start out a trigonometric expression, simplifying it, is you can take trig functions that are not cosine and theta, and you can change them into cosine and theta. So on example number 1, I'm going to use a quotient identity, specifically the tangent quotient identity, which says that tangent of theta is equal to sine theta over cosine theta. So I'm going to replace the tangent with sine theta over cosine theta. And then once I've done that, you'll notice that we have a cosine theta on top, we have a cosine theta on the bottom, and those will cancel out with each other since we have one in the top and one in the bottom. And we are left with sine of theta. So we simplified cosine theta, tan theta, and we got sine of theta. Let's go ahead and pause, copy this example down, and we'll move on to example 2. Right, example 2. We want to simplify cosecant theta over sine of theta using identities. So the first thing I'm going to do again, so I'm going to take cosecant theta and I'm going to change it into something with sine of theta using a reciprocal identity. So if you look at the top of your turquoise paper, you'll find the reciprocal identity for cosecant theta, which says that cosecant of theta is equal to 1 over sine of theta. So I'm going to replace cosecant of theta with that. Now the sine of theta in the bottom is not impacted at all by me replacing cosecant of theta with 1 over sine of theta. So I still have sine of theta in the bottom of my fraction. Now you'll notice that I have a fraction divided by sine of theta. So within my fraction I have a fraction. So what I'm going to do is I'm going to rewrite this as a division problem. I'm going to take my numerator, which is 1 over sine of theta, and I'm going to divide that by the sine of theta. Now the sine of theta in the denominator can be rewritten as sine of theta over 1. So you can see that I have a division of fractions. And when we have a division of fractions, we keep the first term the same. So 1 over sine of theta is my initial term. The division changes to multiplication, and then we take our second fraction and we flip it. We do the reciprocal of it. So sine of theta over 1 is going to become 1 divided by the sine of theta. So now I have 1 divided by the sine of theta times 1 divided by the sine of theta. Now remember, when we multiply fractions, we multiply straight across. So numerator times numerator, 1 times 1 is 1. Sine of theta times sine of theta. Denominator times denominator gives me sine squared of theta. And then my last step, I would like to get rid of the fraction that you see here. So I'm going to take 1 over sine squared of theta, and I'm going to use my another reciprocal identity, which says, it's the same one we started with, 1 over sine of theta is equal to cosecant of theta. So 1 over sine squared of theta is going to be equal to cosecant squared of theta. This is my final answer. Go ahead and pause and record this example, and then we'll move to example 3. Example 3, simplify quantity secant x plus 1 times quantity secant x minus 1 divided by sine squared of x. So the first thing you'll notice up here in the numerator, I have a couple of quantities that I can multiply together. So we're going to use FOIL, first times first, outside times outside, inside times inside, last times last, to multiply this binomial binomial times the binomial, and we'll simplify that first. So let's go ahead and do our FOIL. First set of terms I'm going to be multiplying is secant times secant. I get secant squared of x. Then I have secant of x times a minus 1, so I get a minus secant of x. I have on the inside 1 times secant of x, so I get a positive secant x. And then I have last times last, so I have a 1 times a negative 1, which gives me negative 1. On the bottom, nothing happened. I still have my sine squared x. Now you'll notice these two middle terms are opposites, so they're going to cancel. So I'm left with secant squared x minus 1 in the numerator divided by sine squared x in the denominator. Now if you will go look at your Pythagorean identities, it just so happens that secant squared x minus 1 is equal to tangent squared x. You can find that at the bottom of your turquoise paper with your identities on it. So I end up with tangent squared x over sine squared x. Now my next step is going to be to take the tangent squared of x, and I'm going to convert that into sine squared over sine squared of x over cosine squared of x. So we're going to replace tangent squared with that. So on the top I have sine squared x divided by cosine squared of x, and then in my denominator still I have sine squared of x. Now this once again becomes a fraction divided by a fraction situation when I put the sine squared over 1. So just like we did in the previous problem, we're going to rewrite this as a horizontal fractional division problem. And remember, when I divide fractions, my next step is to convert it into a multiplication problem. So I have sine squared x divided by cosine squared x times 1 over sine squared x. Notice that I have a sine squared x in the numerator, a sine squared x in the denominator, so they cancel. So when I multiply, I'm left with 1 over cosine squared of x, which, if I look at my reciprocal identities, 1 over cosine is equal to secant. So 1 over cosine squared is going to be equal to secant squared x. Let's go ahead and pause, finish copying this example down. We'll move on to example 4. Example 4 simplifies so that our expression is not a fraction. So what we're going to do is we're going to use conjugate pairs. Now a conjugate pair is when you have a quantity and the conjugate of that is going to change the sign of the quantity. So if I have 1 plus cosine of x, then the conjugate pair of that would be 1 minus cosine of x. So I'm going to be multiplying the denominator by 1 minus cosine of x. Now whatever I do to the numerator, I have to do to the denominator as well. So I'm going to be multiplying 1 minus cosine of x in the numerator as well. Now when I multiply by 1, I get the same thing. So in the numerator I have 1 minus cosine of x. We're going to be dividing that by the multiplication, the FOIL of 1 plus cosine of x times 1 minus cosine of x. So very quickly, if I do the FOIL, 1 times 1 is 1. 1 times the minus cosine of x gives me minus cosine of x. Cosine of x times 1 gives me cosine of x. Cosine of x times a minus cosine of x gives me a minus cosine squared of x. Once again, my middle terms cancel. So I'm left with 1 minus cosine of x in the numerator. In the denominator I have 1 minus cosine squared of x. Now at this point I'm going to use another identity. That identity is that sine squared of x, it's one of my Pythagorean identities, is equal to 1 minus cosine squared of x. How do you know when to use a Pythagorean identity? If you see a 1 and a trig function being squared, it's a good indication, if that's all in the same quantity there, it's a good indication that you need to use a Pythagorean identity. So I'm going to use sine squared of x to replace it. So this becomes 1 minus cosine of x divided by sine squared of x. And now I'm going to do a little fractional separation here. I'm going to take, and I'm going to separate it into two pieces. So I'm going to take the first term and put it over 1 sine squared of x. So I'm just taking the first term, the 1. And then I'm going to put minus the second term over sine squared of x. So I've separated it into two pieces. This first term, 1 over sine squared of x, becomes cosecant squared of x. And then the second part, I'm going to rewrite it so that I have 1 over sine squared of x times cosine of x. Okay, I just took the numerator, I put it off to the side, I put a 1 in the top over sine squared of x. And then this part also becomes cosecant squared of x. So my final answer is cosecant squared of x minus cosecant squared of x cosine of x. Okay, we have simplified it so it is no longer a fraction. You could then take this and simplify it a little bit more, but we've gotten it to where it's not a fraction, so this would suffice. Go ahead and pause, and we'll move on to the last example. Okay, in our last example, we have cosine of x divided by 1 minus sine of x minus sine of x divided by cosine of x. I have the subtraction of fractions, so if I were to work this problem, I would need to get a common denominator. So let's go ahead and get a common denominator. The denominator that's going to be the common denominator we're going to find by taking our denominators and multiplying them together. So the numerator up here on my first term is going to need to be multiplied by cosine of x, and I'll multiply the denominator by the same thing. And then for our second fraction, we're going to multiply it by 1 minus sine of x. And so whatever I do to the bottom, I do to the top. And so now we've gotten a common denominator. Now I'm going to simplify my numerator. Cosine times cosine is cosine squared of x minus, now this is a quantity, so I'm going to keep it in parentheses for the moment. Sine of x times 1 is sine of x. Sine of x times a minus sine of x is going to be a minus sine squared of x. And then on the denominator we have cosine of x times 1 minus sine of x. Now for our numerator, we're going to go ahead and distribute this negative. So in the numerator we have cosine squared of x minus sine of x, and then a minus times a minus becomes a plus sine squared of x. And then in the denominator we have cosine of x times 1 minus sine of x. Now, if you will look at your Pythagorean identities at the bottom, you will see one of your identities that said cosine squared of x plus sine squared of x is equal to 1. Well, right here I have a cosine squared of x, and right here I have a plus sine squared of x. So if I wanted to, I could rewrite that numerator like this: cosine squared x plus sine squared of x, as long as I take the sign with it and keep the minus on the sine of x. So I just rearranged them. That's called commutativity. As long as you keep the sign with it, you can do this. Well, what is cosine squared of x plus sine squared of x? If I add those together, I get 1. So I have 1 minus sine of x over cosine of x times 1 minus sine of x. And from algebra, we know that if you have the same quantity in the numerator and in the denominator, and it's all multiplication, then you can cancel them. Well, this quantity, I can put parentheses around it just to make it look more like the quantity. This quantity and this quantity are exactly the same, so they can cancel because it's a multiplication problem. Now, what are we multiplying by in the top? If there's not a number out there, we know that it's a 1. So we have a 1 left in the top, and we have cosine of x left in the denominator. So we have 1 divided by cosine of x, and from our identities we know that 1 divided by the cosine of x is equal to secant of x. So we have simplified our original expression, cosine of x divided by 1 minus sine of x minus sine of x divided by cosine of x, and we got it to the final answer of secant of x. Go ahead and pause, finish up your notes, and we will see you in class. Have a good evening.